Hello, everybody, and welcome to this week's Gardener review meeting. This week, we're focusing on the release 1.135 for Gardener. Let me show you the agenda that we have for today. This release phase was a bit longer due to the change of years, so we have more changes in this release. We'll start today with Alexander, who's talking about automatic credentials rotation during shoot maintenance, followed up by Luca is talking about a bug fix that remediates outdated service account tokens. After that, we'll have Dominic with the highly available VPN round-robin bonding mode or a feature gate for that. Next up, there's Vladimir talking about multiple changes that add support for workload identity as a credential for DNS. Then we have Victor extending the health check in the care controller also to check Prometheus for its health status. And the second to last topic, we have Konstantinos talking about managed resource support in the generic ControlPlane Actuator, which is actually a hackathon follow-up. And towards the end, I'll briefly talk about the retention of Kubernetes versions in Gardener. That being said, we have a packed agenda. Over to you, Alexander.
Okay, hello, let me just share my screen. So I'm going to talk about this new feature, an added option to enable automatic credentials rotations during the maintenance window. So to configure this, you need to set one of these fields for either observability credentials, SSH key pairs or nodes, or it's the encryption key that's used for encryption at rest. They're disabled by default, so you need to actually set this field, and you can set here the rotation period from the last rotation, how much time until the next one. This new feature actually uses an improvement from a previous release that now allows during in the garden operation to set a number of operations, and actually when you set, for example, HD key and SSH key pair in the maintenance rotation, these annotation operations will be added, the rotate SSH key pair and rotate HD encryption key. Also, the maintenance operations will also be added in the maintenance window, so everything actually happens in a single maintenance window and you do not have to wait for the next one. Well, this is the change I wanted to present. Any questions?
Thanks a lot, Alexander. Doesn't
Thank
sound
you.
like there are questions. Thanks for presenting. Then over to you, Luca, with the remediation for outdated service account tokens.
Yeah, thank you. So this is a bug fix that occurred in our landscapes in connection to the provider AWS extension, but it's a more generic issue. The problem is that if a service account is created and we create a secret for the TokenRequestor to populate with a token for the service account, and then the service account on the target is deleted and recreated, so it's the different entity with a different UID, the TokenRequestor would, before this fix, not re-request a new token because it sees its validity or the renew timestamp it has set on the secret is not yet expired. So a glimpse in the code, before we had it checked for an existing token that it already populated, and if it does not exist, it renews automatically, which is sane. And if it existed, it waited for the renew timestamp to occur. So I fixed this. It will now check via token review whether the token it has populated is actually still valid. And if it's not, because, for example, the entity has changed, it would request a new one. So quick demo. I have here my TokenRequestor secret, it's already populated. I have my corresponding service account, and I can also see that the token is issued for the same entity. So formally, if I were to delete the service account and create it again, if the token requester was to run its reconciliation flow again, it would not renew the token, but we can, for example, by annotating this one, see that now it actually checks that it has performed the token review. It was not valid, so it will request a new token, even though the expiration timestamp was not yet due. So this is a little fix here. Are there any questions?
Thank you, Luca. If there are still questions, also feel free to continue in the chat. Otherwise, over to you, Dominic.
Yes, thank you. Let me just start the share. Can you see my screen?
Yes, it's visible.
Okay, thanks. I have a couple of slides and a little demo. Okay, HAVPN round robin. Okay, so what is this about? As you know, in the HA control plane scenario, we also have an HA VPN running that uses 2 VPN servers. Those 2 VPN servers are currently used in active backup mode, which means only one of them is used by default, which works fine if you have a regular operation kind of scenario where you just need to restart both of the servers in a controlled fashion, but it doesn't work very well if you have a degraded network condition, for example, packet loss on one of those. And the fix I'm introducing now is a round-robin mode feature gate that allows you to basically use both of them at the same time. So what's changing? We will introduce a feature gate called VPN bonding mode round-robin, which is disabled by default, but we intend to graduate it over time. Main reason being that it's a very key component in the communication between seed and shoot. It should not cause any problems, but we try to be rather cautious with this change and first roll it out slowly and see that we don't break anything accidentally. A quick recap on maybe a refresher on what's bonding. So bonding basically means it's a feature of the Linux kernel that allows you to link 2 physical devices together and form one logical device that you can then use as if it were a network interface. In our case, we have 2 logical devices, the tab devices that are opened by VPN. And we bond them together to form one logical tab device that is used on both ends of the connection. So we have on the left, we have the Kube API server, and on the right, we have the VPN shoots. We have 2 VPN shoots actually to also have HA on the shoot side. And of course, we have multiple Kube API servers in the HA scenario as well. In the default, like I mentioned, there's a policy in place called active backup, which means the bond device will always prefer tab 0, which means VPN seed server 0, so the upper one, and the lower one is just idling, it's standby. This has the advantage that you don't get disagreement on both sides, like which of these 2 VPN servers should be used for traffic. And it avoids outages where one side uses VPN server 0 and one uses VPN server 1. So that's nice. If you have a scenario where you need to restart VPN server, for example, if you do an upgrade, VPN server 0 goes down. OpenVPN recognizes this, the connection is lost, and it shuts down tab 0, which will then trigger the bond device to fail over to tab 1 and use VPN server 1 temporarily. once VPN server 0 goes back up, it goes back to the default mode of using the tab 0 and just using VPN 0, VPN server 0. So that's all fine and good. The problem occurs when you have issues on the node of VPN server 0. The problem is as long as this tab device is still up and the connection is technically fine, the bond device will not switch. So it will just keep using this broken VPN server. And the problem is that depending on how much packet loss you have, your webhooks might fail, your shells, your logs, streams, whatever it is, might fail. And the problem is that there's no automatic fix for that. So the worst scenario we saw is an outage over half an hour before the operator basically removed the node and caused VPN server 0 to be placed on a different node where we didn't have that problem. So we tried multiple things to make this better. What we tried initially is making this whole switching thing kind of smart. Turns out trying to be smart is often not the best idea because it's very hard to get it right to agree, to have both sides, the seed and the shoot side, agree on which VPN server should be used now. Consider you have a scenario where the left side has a ping that goes through. It just happens to work, so it sticks on the VPN server 0, but the right side, the ping fails and it makes the switch. So now you have an outage because both sides can no longer talk to each other. And no matter what you do, you basically are stuck with this scenario. When you are very aggressive and you say, okay, I need, I immediately switch over when like 1 or 2 pings fail, it turns out during the testing that you constantly flop over. You constantly go back and forth between the 2 VPN servers because the smallest disturbance in the network flow will cause you to constantly switch. So you might as well just go round robin anyways. If you are more relaxed and take more time, then the problem is, for example, you take 10 pings. Okay, now eight of those 10 pings fail, but you don't have your threshold reached, so you stick with the broken network connection. So that's bad. But if you switched, you need to then wait for the other side to also make the switch, which also takes 10 pings. During that time, one guy has switched, but the other one hasn't, so you have an outage. The problem is this: the time for the 2 sides to agree is just too long to avoid timeouts on your webhooks. So instead of trying to be smart, during the testing, we just saw going a very simple way of using both VPN servers at the same time, using the round-robin mechanism, turns out to be the superior method. What's happening here is that all of these devices, the bond device, tab devices, they all get the same MAC address. So on the network layer 2, they look the same, and they are indistinguishable on the other side. So this bond device on the right-hand side doesn't even know if the traffic it got came from VPN server 0 or VPN server 1, and it doesn't care. It's very simple, and it works the same way. If VPN server 0 goes down completely, it will just turn down this tab 0 device and use only one device. And if you have a network degradation, for example, here we have the same VPN server seed 0 degraded. The first SYN doesn't make it over. So you just retry your connection on the other side. Oh, this guy goes through, but the ACK doesn't go back. So there's a second ACK. TCP, thanks to TCP, we have retries. and the second ACK goes through to this Kube API server, and it just works. It's not great, like you don't have high throughput or whatever, but your connections end up working, and it works up to basically 1/3 of the packets getting lost on this one node. So with this, I have a small demo. Let me just switch over. I should have it right now. Too many. Okay, so here I have a standard seed shoot combination where we still have the active backup in place. On the right-hand side, I'm on the node where VPN server 0 is running on the seed side, and on the left side, I have a little shoot pod. That's just some Ubuntu running to just simulate some connection. Let me just start this one. Okay, let me just do a little sleep loop here. Print the date. Oh, I forgot to do one. Okay, now this guy just has opened a TCP connection and just keeps printing the date, and it should stay up all the time. If this one goes down, you basically have an outage in your connections. On the right-hand side, I would just cause a little traffic problem by introducing a packet loss. So I'm here, have a little script that allows me to run arbitrary commands on the pod IP. I will use TC, queuing discipline, add to the device 0, root queuing discipline, network emulator, and cause 30% traffic loss. Whoops. Hold on, we got it up here. I hate this guy. Let me just go back. It should be working.
I think maybe you were missing the loss.
I forgot the loss. Yeah. Now it's working. It should be working. Okay. So here, let me just jump into one Kube API server real quick, put up the logs, and here we see timeouts, and it's complaining that it takes too much time for the pings to go over, and eventually it should reach a point where this connection on the left side will fail. So there it is. Okay, now my shell is dead, and this is basically what causes your outage on the regular active backup scenario. Let me just undo this here. Okay, now it's back to the regular state. And now I have a different scenario where exact scenario, but I have the round robin in place. So here I will do the same while loop. Okay. And now here I have, whoops, I just lost my shell. Okay. Go back here. Now I need to copy over this tool again. To my enter. I didn't want to disrupt the whole node because there are so many other shoots running next to me. So yeah, okay. me just get the IP address. So this is my IP. Just double check. Yeah, that's me. Okay. And we have the TC stuff. Okay. Now we have the same scenario. And let me just also bring up the logs of the Kube API server. Okay, we see the same kind of problems in the logs where it complains that the pings take too long. But as you can see, maybe just wait a second. It still keeps printing out the date. Yeah, and I think that's it. Sorry I ran over time. It took a little while to prepare, but yeah, we will hope to run to basically graduate this feature gate and just increase the availability of the VPN in total. Thanks.
Thanks a lot, Dominic. No worries, we're still good on time. Are there any questions for Dominic? You set the bar pretty high for today with an actual slide deck and complex live demo. Well done. All right, if there are no questions at the moment, then let's continue with Vladimir and the workload identity support for DNS. Over to you, Vladimir. You're still muted?
Oh, yeah, I think now I am unmuted. So I hope now you hear me and also see my screen. So I will talk about the workload identity progress with regards to the DNS credentials. So these are the final steps. And basically it will be about 3 pull requests. One is about editing. Two of them are actually for adding new fields to the shoot and seed API. So far, the DNS providers had a field called secret name, where we can specify secret with credentials to manage the DNS records. In the seed, we had also similar field with secret name. It is also extended with new field credentials ref. And the final PR is actually making these new fields usable, and not only usable, but also allowing workload identity to be referenced from them. If we take a quick look, in the past, how I was looking seed, actually not so far in the past, because the default and internal domain were made explicitly configurable relatively recently, but they were supporting just secrets at the beginning. Now we can also reference workload identities and use them as credentials. And the new field is actually this in the provider, DNS provider, which was previously secret ref. Now it is also credentials ref. So yeah, this I think it was something like name, whatever. Anyway, and for the shoot, we have similar change. Each DNS provider could have specified secret name in the past. Now there is a new field called credentials ref. The Gartner API server take care to sync both fields. So if you still using secret name, a new field will be automatically set. Will be referencing resource of type secret with the same name, but you can also reference workload identities. And because workload identity is not a secret, it will not be synced with secret name. So you can see that here we don't have secret name. And quick demo, I have set up local instance of Gardener, which is using only workload identities. And if I get the seed cluster, here you can see I have set up workload identity as default domain credentials, also workload identity for the internal domain, and for the seed DNS, we're also using workload identity. So if I move to the seed cluster and I get all of the DNS records here in the cluster, I have the seed ingress And for my shoot cluster, also the default and internal domains, DNS records created. If we take a look in one of the DNS records, it is this is seed cluster and it's still using secret. However, the secret is a bit different. And if I describe in the secret, it does not contain any AWS secret access key or access key ID and so on. It just gave a config and token. The config is the workload identity config. In this case, it just specified the row ARN that will be assumed. And maybe the interesting part is if we take a look in the token. This token is just ID token with quite a lot of claims specific to the gardener, which is the project using the token, the seed, the shoot, the workload identity, and on the AWS side, we have configured this token to be trusted, and the role that it is assumed with this token, it is granted permissions to manage DNS records in AWS. And this is pretty much how the other two records are managed. And maybe just final words. Here with for the shoots, we have also shoot DNS service extension that is also adding support for workload identity very soon. So with this, I think we will cover all of the scenarios where credentials of type workload identity can be used in Gardener. So it's pretty much everything from my side. If there are any questions.
Thanks a lot, Vladimir. It seems like there are no questions at the moment. You can always ask in the chat in the meantime. Let's continue with Victor and the Prometheus health checks in the care controller. Over to you, Victor.
All right, then let me share. Okay, that just a moment. Okay, perfect. Now I'm all set. Yes, so hi everyone. Today I wanted to present this pull request that Istvan and I have been working on in the last weeks. The idea of this pull request is very simple. What we did here was to extend the care controllers that currently we have. So for the garden, for the seed, and for the shoot resources, to also open a connection to Prometheus, send a query, and based on the result of this query, set the corresponding conditions in the set the observability condition in the corresponding resource as true or false. We took this idea, or it is from what the Gardenlet is currently doing to check for the health of the API servers of the shoots, that it opens a connection to them, and then it's an HTTP request. I don't know exactly how it works, but the concept is the same, that we don't only check for things that are in the cluster, but also actually actively send some queries to Prometheus. The motivation to do this was because until now, we only had, or the only health checks that we had for the observability components were mostly relying on the GRM or on the managed resources, and these are essentially checking that the pods are running. So if the managed resource, so if all the pods are running, the managed resource is usually happy, and then that means that also the conditions were happy. But in the last year, we had some situations where there were some regressions, some metrics were missing. This was not detected in time. And then when we wanted to look like debug or to look into retrospective what had happened in the previous weeks, then oops, the metrics are not there. And we wanted to improve this so that we can catch these things a bit earlier. And then the idea of doing this with the conditions, it was for two main reasons. The first one is that then it's very obvious in the Gardener UI in the dashboard to see that there is a failing condition. So it's very obvious for the operator or whoever is responsible for the Gardener landscape that there is an issue. And the second benefit, which is the one I really like, is that now, because that's how the end-to-end tests work, that they assert that the conditions are healthy to decide whether the test passes or not. Now we could catch regressions during pull request validation. So if someone has a pull request that changes some script configuration and then this script configuration is not doing what it's supposed to do, now we have a good chance to catch this during, as I said, during pull request validation. Yes, one last aspect before continuing, just about the introduction. Yeah, this feature we expose behind the feature gate. We want to remove this feature gate eventually, but for now it's there and it's disabled by default, so you don't get this feature just out of the box. It's only enabled for the local setup, which is what the pull request validation uses. Before starting with the demo, I prepared a small slide with a very simplistic diagram that tries to explain how this works so that I can give you some context for when I do the demo. So as I said, we have done this for the care controllers. We have 3 of them. Yeah, maybe just one small thing, like probably it's very intuitive, but blue things or the blue boxes here, it means Kubernetes resources, and the yellow ones are pods. And as I was saying, we have these 3 care controllers. One is in the Garden operator for the Garden resource, and in the Garden-led, we have 2 for the seed and the shoot resources. But the concept is the same. So the idea is that now these care controllers, when they want to run these checks, the first thing they do is they list Prometheus based on this new label that we introduced with this health check by to differentiate to separate these responsibilities from the Garden operator and the Garden-led, for instance, when the runtime cluster is also seed. And with this listing or with this Prometheus resource, the care controller has all the information it needs to know what is the Prometheus pod that it needs to be queried, and it fires a query like this, just a health check up. This is what I will show in the query what this means. And based on the result of this query, if this returns 0, we consider this unhealthy, and if returns 1, returns healthy. This we took the same semantics that from this up metric that Prometheus has. So when you deploy a new script job in Prometheus, it automatically creates a metric called up, and it has this meaning, it's 0 or 1. What happens meanwhile or asynchronously in the Prometheus is that there are some recording rules, or we deploy with a pull request some recording rules to do this health check evaluation. And they are, as I said, they are running asynchronously. They're evaluated every minute, so it's not part of this. So they are not executed when the query comes from the care controller. And then we have 2 kinds of recording rules. So first one is just called health check. This attempts to be with a labeled task. This tries to be, or we try to add 1 check for every specific aspect that we want to validate, or that we want to check validate the health. So we cannot really validate the complete database, but we can do is have a health check, for instance, to validate that all the script targets are up and running, that maybe the service discoveries are also doing what we are expected to do, that all the script jobs are ingesting some metrics, so to validate the script configuration and so on. And then we can have that we don't have for now, but we could also eventually add some specific health checks to assert the presence of certain metrics. So at the moment we only have this, or the pull request only introduces this for metering metrics. But I don't know if eventually in Gardener we have some use case where we want to query Prometheus to support some decision, like, I don't know, scheduling, auto scaling, whatever. This is just brainstorming, just for the sake of explanation. Then it would make sense to have a health check rule here that asserts that those metrics needed are present. So yeah. And then there is another health check rule, which is this health check app, which essentially is doing a count on these other health checks and transforming it into 0 or 1. So if there is some of these health check rules fail, the health check app will return 0. If everything is fine, it will return 1. Yes, and then one last thing is that then what is written to the conditions is just a very fixed generic message, which is basically telling you something is failing in this spot. Please access the Prometheus UI and check it. But that's what I will show in the demo now. So for the demo, I have prepared a remote local setup, and I'm port forwarding to the dashboard in this local setup. The demo, I will try to do it only in the Gardener dashboard, because I think that's where it's more visible to see that the conditions are failing. And because it takes some time to Prometheus to detect new script configurations and so on, I already deployed some buggy script configurations. So that's why you can see that, first of all, here I have a couple of shoots. One is the call local, and the other is a managed seed. And for the local, for instance, there is already the observability components condition that is failing, as I said, because I have already deployed a buggy script config. So, and this is the error message that I mentioned. So it's just telling you which pod is problematic, and please access the Prometheus UI and query for this thing for more details. So first of all, let's go to that Prometheus, which I'm also port forwarding. But before we do that, let me explain. Let me go back to this health check app metric that I was explaining, so that we completely see what it does. So at the moment it's 0. That is valid because there is a health check issue. And if we look at the graph, maybe for the last 2 hours, so you can see that it was healthy. This is when I prepare this demo. So you can see that originally, well, it always starts with 0 as unhealthy. We do this on purpose. This is to enforce, because at the beginning, the rules or the health checks are not evaluated yet. So in this sense, we're pessimistic and we say, okay, I don't know what's happening. So I'm going to say, I'm going to fail the health check. And then when everything is running, then it becomes healthy. And at this point, where it goes down again, is when I introduce or I added this script config that I'm saying that it's failing. Okay, we can also just shortly take a look at these rules that we introduce. So we can do this for health check. Health check. So there are this many, maybe just 2 or 3. So these are the generic ones that I was mentioning. So there is a health check that will fail as soon as there is a job that is down. Another one that will fail when the service discovery is not working. And another one that maybe that validates that we are actually ingesting metrics from that script. Yeah, okay. And then coming back to the error message that we had here, or the condition message, it was telling us to check for this health check metric. So if we go to the query here, this is mostly what an operator could do or how we could debug things. So you would come to the Prometheus UI and then look for health check, and then you will have you will see the failing metric. And in this case, maybe this is where it's a bit tricky, and we need to have a bit of understanding of Prometheus because you have to read these labels. And in this particular case, we have a task. This the label that we introduced with the recording rule that it says target down, and this means that there is a job that it's failing. So we could go to the target health here, and maybe we could search for all pools, and here somewhere there should be a job that is failing. Exactly. And this, you can see, this is failing. This is what I meant. This is a script that I introduced, and this is simulating Prometheus scripting itself, but it's doing it in the wrong path. It's doing it on /metrics failing, which doesn't exist. So this fails, and therefore the condition fails. And yeah, and just to finish the demo, because I mentioned that I have also managed seed, so we could also look into that. In this case, for the seeds, we don't have a specific observability components condition. That's something that we want to introduce in a follow-up PR. But for now, the observability components were always reported in the seed system components condition. And here the message, as I said, is the same, but now it says it's for the cache Prometheus. So we could do the same exercise and go here. This is now the cache Prometheus. And then if I do health check, then what we will see is that it's failing for a task that is called script empty. This I can already say, this is expected. This is what I did here. The buggy, or what I did here was to deploy an exporter that doesn't return any metrics. So it's essentially a pod with an HTTP server that returns empty responses, and then the health check failure happens. So we can look into the target health, and I could filter here by down, but everything is fine, because in this case the error is something else than what we see in the shoot. But anyway, what I cannot do for the demo, because it takes a couple of minutes, but I want to mention is that if I could now go and fix these script configurations, or maybe just remove them because they're just for test, then after a couple of minutes this health check will be up again and the condition will be set to healthy. And yeah, that's what I wanted to show for today.
Thanks a lot, Victor. Are there any questions? I do have one. The diagram that you showed before, is this part of the pull request or otherwise part of the documentation?
No, I prepared this for the review.
Okay. Up to you to decide, but I feel like it might be valuable to keep it around.
Okay, then maybe I can do that. Thank you.
Thanks
That's a valid input. Yeah.
All right. Thanks again, Victor. We're almost through with the agenda. Second to last topic, we have Konstantinos with the managed resource support in the generic control plane actuator. Over to you, Konstantinos.
Hi. Thank you for having me. Let me share my screen. Okay, so this is the pull request. It's basically a change that we implement initially in the hackathon, I think around 2 hackathons ago with Garrett. The overall idea is quite simple. Basically, so far, like when we are reconciling the control plane of a shoot, right? It's split into deploying resources in the seed and split into resources deploying resource into the shoot. We always deploy the shoot resources with a managed resource, and then the idea behind that is that why do we not do the same for the seed resources? Because previously we were just deploying charts, and when you're doing application of charts, then you end up with some tricky situations because you have to do everything imperatively. So you could, for example, not just remove like a chart that you use to deploy in the control plane, because once you remove it from a chart, it was just not getting reconciled. You have to do some imperative things like keep replicas of a deployment to 0, and so on. And the idea is that now, with actual reconciliation of this resource that we deploy in the seed for the shoot via managed resources, then it would make our lives easier. So this is relatively small changes. You can also select 3 files. So what would happen once an extension re-renders the package? I already have created a shoot here in the provider local, and if I list the managed resources now of the shoot, and you will see this extension control plane seed. This is the new managed resource that you will see in your suits managed resources. Let's see. So I will say that for the purpose of the demo, I did add something, so it's not so easy as you can run the provider local for you to test. That's only because the provider local does not really deploy anything in the control plane normally. And so I just added like a random chart that I did during the development. And that's just like this static, just an Nginx pod. And you can see here that I have my managed resource for the control plane seed. And yeah, it contains basically the chart. And here, if I see in the seed namespace, this is the Nginx, right? So that's about all for the demo. It should be completely, transparent for users. Like once you revender it, then you should see nothing change. It's just the deployment that you used to do through the the generic Actuator did for you, but instead of being just a simple chart, then you should see a new managed resource. And after you revender it, then from the next release of your extension, you can consider removing any any logic that you had to scale replicas down to 0 and so on and so forth. And that's about it. TLDR, you should see no change. No change in behavior or anything. You should just have your life being easier. And that's all. Questions or anything? Nothing? Amazing. Back to you, Mark.
Thanks a lot, Konstantinos. Sounds wonderful. Then moving on to the last topic on the agenda for today. I want to briefly talk about the Kubernetes minor version retention in Gardener. It's about this PR that was open for quite some time from last year to this year, where we basically want to move down from supporting 5 Kubernetes versions in Garden at the same time down to a target of 4. With this PR, we also introduce this minimum lifetime of 14 months that Gardener supports a Kubernetes version. And we've done this reduction in the past already, so I just quoted the same motivation from before, which is primarily to align more with how Kubernetes treats and supports its releases, and being a bit more aggressive here in dropping older, potentially outdated or even vulnerable versions from the whole code base and motivating landscapes and everybody else to update more frequently. To show you the changes a bit played out in our documentation. So for the people on the Kubernetes release responsible plan, most notably here, we have this line talking about dropping support for previous versions. So the goal is to support 4 in parallel. With an addition, we want to make it a bit more reliable or plannable regarding the timeline of these support frames. So whenever we introduce support for a new Kubernetes version in Gardener, from that point in time, it should stay in for at least 14 months. It can be longer, but not shorter. To see this in detail, you can head also over to this supported Kubernetes versions table, which has been extended a bit, gives you the overview of the current Kubernetes versions that are supported, when support was added in the main Gardener project, and then based on these 14 months, the minimum of, for the time they're supported until. Lastly, maybe talking about the elephant in the room. If you're looking at the Kubernetes conformance page of the project, you currently see that we have, again, 5 versions supported in parallel. So after now doing this change, we're giving a bit of transition time for landscapes and everybody to adjust to this change. But nonetheless, hopefully with the 14 months, it should give everybody a better idea of the timelines involved. Any questions for this topic? Does not sound like it. This was then the regular agenda that we have. There's one more thing that I wanted to mention. As you're aware, we have this 2-week planned release cycle for Gardener. There's currently a pull request open by Tim for adjusting the release responsible schedule, or the release schedule, if you will. Most notably meaning the next upcoming release 1.136. The release period would be extended by 1 week. Motivation for this is we need to bring this back in sync with internal validation processes that we have. So this would mean, if we're looking to the changes, next release release phase would have gone until the 8th of February. This would then be shifted to the 15th. And if this is merged, we would have the next review meeting in 3 weeks from today instead of 2 weeks. So you would see this also in your meeting invitation. If this is a deal breaker for you, please speak up in this PR. All right, if there's no question for this, then thanks to everybody for joining this meeting today. Thanks to all the presenters for taking the time to prepare and present today. And of course, everybody contributing to this release. With that being said, have a very nice day and see you most likely in 3 weeks. Thanks, everybody.
Thank you. Bye-bye.